Today we're going to look at some amazing false mixing procedures that have never been shown before I discovered them for the Hidden Structures online course. Okay, so you're seeing something that is brand new to the world of card magic, and in particular mathematical card magic. Now, you may have watched videos in my series devoted to the third time's a charm principle, in which if you repeat certain actions 3 times, surprising things happen. Well, here we only have to repeat the same action twice, just 2 times, and then the magic occurs. Okay? So what we're first going to look at are packets of size 8, 9, 10, and 11. And then we'll look at some smaller packet sizes as well. Okay, so I have here a packet of 8 cards in sequential order in clubs. This will enable us to see whether or not we succeeded in preserving the original order of the cards. Okay? So how this false mixing procedure works is if you're given any 8 cards at all, or if 8 cards are in play for some other effect that you're doing, there is a way to, quote, mix the cards but return them to their original order. But boy, does it look like the order of the cards would have to be beyond the knowledge of anyone, especially since the spectator is going to be allowed to choose any one of the 52 card names to use. Okay, so let me go ahead and just illustrate this. So I have 8 cards here, and so what we can do is just ask the spectator for any card in the deck. So maybe they'll say the Ace of Diamonds. Okay, so if we spell the Ace of Diamonds twice, it will return this packet to its original order. Okay, so Ace of Diamonds. So how we'll do the spelling is as follows. So A-C-E, of course for Ace, O-F-D-I-A-M-O-N-D-S. That's Ace of Diamonds spelled once. A-C-E-O-F-D-I-A M-O-N-D-S. That's Ace of Diamonds spelled twice. Have we returned the packet to its original order? Well, it's looking promising. We have indeed. Now, it doesn't matter which of the 52 card names you use for this most remarkable spelling system, these cards will be returned to their original order. Well, hopefully just knowing that should get the wheels of your creativity turning as to all the different ways that you could take advantage of this property. Because anytime you have a packet of cards in which the spectator believes the cards have been randomized or mixed beyond the knowledge of anyone, and you have complete knowledge of the ending packet, boy, does that give you tremendous power to do just about anything you want with the cards. Okay, so that's for 8 cards. Now, of course, we haven't verified it for all 52 cards, but I invite you to do so. If you have the stamina, it will indeed work for every one of the 52 card names. Now, the reason it works, if you want to go to the linked videos in the description below, it will take you to my Hidden Structures Bootcamp series, in which we talk about the idea of hypercoding. And it ends up that 2 identical hypercodings of a packet of cards returns it to its original order. So we're using that property here. Okay, so we've kind of verified it, at least in that one instance, for a packet of 8. Let's move on to a packet of 9 cards. So I have Ace through 9 of hearts. And I really wish you were here because I could have you choose any of the 52 card names. So maybe you would choose 3 of clubs, let's say. Okay, so we're going to spell 3 of clubs twice. T-H-R-E-E-O-F-C-L-U-B-S. That's 3 of clubs spelt once. T-H-R-E-E-O-F-C-L-U-B-S. And the claim is we've returned the packet to its original order. And as you can see, we have indeed. It's back to its original state. Okay, so that's for 9 cards. Let's go ahead and look at 10 cards. So here's a packet of 10 cards in order so we can kind of see what's going on. So you're free to choose any one of the card names. A popular card name for people to choose is the Queen of Hearts. So why don't we go ahead and use that one? So Queenofhearts. That's one spelling of Queen of Hearts. Second spelling now. Queenofhearts. Did we return the packet to its original order? We did indeed. Amazing, amazing. Try it for any of the 52 card names. It works. The last one for which this property holds is a packet of 11 cards. So let's go ahead and have you randomly choose any of the 52 card names. Why don't we choose one that's maybe not likely to be chosen by people? 6 of spades. Okay, probably not going to be chosen as a favorite card too often. So 6 of spades. S-I-X-O-F-S-P-A-D-E-S. That's the first spelling. S-I-X-O-F-S-P-A-D-E-S. That's the second spelling. Did it return it to its original order? It did indeed. In fact, you may have noticed something interesting about the particular spelling for 6 of spades for a packet of 11 cards. We actually went through all of the cards in each of those 2 spellings. We didn't need to go beyond the number of cards in the packet here. In fact, that's a little bit of a hint that you cannot actually push this principle or property to a packet of 12 or larger number of cards. It won't work in every case. The same thing for 7. 7 ends up being too small. It won't always work for every one of the 52 card names. Okay, so that is the first amazing false mixing procedure I wanted to show you today. The second one is also very interesting and a lot of fun. This time it involves smaller packet sizes that use any one of the 4 suit names. Isn't that fun? So let me go ahead and kind of set that up. Okay, so for packets of 4, 5, or 6 cards, here is a, quote, false mixing procedure that will always work and return the packet to its original state. So here I have ace through 4 of clubs. So that's the smallest packet size for which this is going to work consistently. Now the spectator is free to choose any of the 4 suit names. Suppose they choose hearts. So H-E-A-R-T-S. That's the first spelling of hearts. H-E-A-R-T-S. That's the second spelling of hearts. Has it returned the packet to its original order? It has indeed. And you can test this for the other 3 suit names, and it will work just fine. So let's move ahead to a packet of 5 cards. Is it going to work that if I spell any one of the 4 suit names, that it will return this packet to its original order, even though it looks like it's mixing up the cards to some degree? Well, let's test it. So maybe this time for our randomly chosen suit, why don't we go with diamonds? That might be a good one. So a D-I-A-M-O-N-D-S, that's diamonds, spelled once. D-I-A-M-O-N-D-S, that's diamonds, spelled twice. Did it return these 5 cards to their original order? It did indeed. And so try out the other 3 suits and they'll work just fine. The last one is a packet of size 6. Okay? And so why don't we choose maybe a different one, I suppose, clubs. We'll choose clubs this time. So we can do a C-L-U-B-S, drop the last one on top. C-L-U-B-S, drop the last one on top. How did we do? It returned the packet to its original order. Now, something interesting happened in that particular case. It doesn't happen very often, and it causes no issues for us. But it ends up that clubs has 5 letters in it. 1, 2, 3, 4, 5. So it ends up that in some ways, we don't technically go through the whole packet, even once, right? Because as we spell out clubs, so C-L-U-B-S, we still have this card remaining. With all of the other spellings, we either also put this down as an essential part of the spelling, or we had to go beyond this. We had to put this down and then finish spelling that word, okay? So that's kind of interesting, but it ends up that it poses no problems. And so you can go ahead and spell out clubs, hearts, spades, or diamonds for a packet of 6 cards. Now, this principle does not apply to a packet smaller than 4, and you can check that. So it's only 4, 5, or 6. Now, one thing that just occurred to me before recording this video is that in some ways we could actually combine both of these together, perhaps in a fun way. Okay, so let me just put these up to remind you. So for example, if we allowed the spectator to choose any one of these 8, 9, 10, or 11 cards to work with, and I guess I should point out also that it won't be too difficult for you to see how you can use this, because it has the same benefit as any false shuffle. So a false shuffle is a shuffle where it looks like you're mixing the cards, but you're not. The cards are still in their original order, or some of them are still where they started out to be. So if you have seen demonstrations where false shuffling is used, and it's used a lot, this is the kind of thing that you can do here with smaller packet sizes. 4, 5, 6, and then 8 through 11. You have this wonderful false mixing procedure that sure looks like it's mixing up the cards reasonably well. Okay, so why don't we say the person chooses to work with 11 cards, okay? So one thing we could do is we could go through, and I guess we can just do it right now, but we could go through and spell any of the 52 card names. Perhaps one that we haven't thought of yet is 10 of diamonds. 10 of diamonds. So T-E-N-O-F-D-I-A-M-O-N-D-S. So that's one spelling of 10 of diamonds. T-E-N-O-F-D-I-A-M-O-N-D-S. Okay? Now, before showing the spectator, you wouldn't have to stop here. Now, we know where we are. We're back to the very beginning. We've returned the packet to its original state. But you don't need to show that at this point. Tell the spectator that you're going to divide the cards in half. Now, you can't quite do exactly half because 11's not divisible, right, by 2. So here I've gone with 6 and then 5. You could do 5 or 6 over here. It wouldn't matter. So I've kind of like divided it roughly in half. And now think about it. What do we have now? What's the size of this little packet? It's 6. It's within our range. Okay? So at this point you could say, well, let's do some randomizing of these 6 cards. Why don't you just randomly choose any suit name? And so maybe they say hearts. So you spell it twice, H-E-A-R-T-S, for spelling of hearts, H-E-A-R-T-S. So what's nice about this is all of the spellings are being done twice. So there's a uniformity of action that's very important in mathematical card magic as well as magic in general. Uniformity of action is very important, because otherwise the spectator will wonder, well, why did you do things differently here versus there? And it'll make them suspicious as to, oh, he's hiding something, right? So we spelled out their name suit twice. Okay, now over here, what's the packet size for this one? It's 5. It's within our range. So we could say, well, we can use the same suit name that we used over here, or we can use a different one. Which one would you like this time? Spades, okay. S-P-A-D-E-S. That's a first spelling of spades. S-P-A-D-E-S. Okay, very good. Okay, so we've really kind of mixed up these cards. So let's go ahead and see where that has led us. Okay, so we started with that original packet. You randomly chose a card out of the 52 cards, and I just spelled it twice. And then we just broke up the cards roughly in half. We had 6 and 5, I think. And then you actually randomly chose, in fact, a different suit to use for a spelling out of each of those piles individually, and then we just stacked the piles back together in the way that we had unstacked them, okay? So no shenanigans here. So how did we do? Where did that take us? Oh, that's interesting. Ace was the top card at the very beginning. Isn't that it? Wait a second. 2 was... No way! Do you have any idea how likely this is to happen by chance alone? The probability for this is just dropping through the floor. There's no... I can't believe it. You actually put it back in the exact original ordering at the start. How did you do that? You just happened to choose a card name that when we used it twice in our spelling, followed by a dividing of the deck roughly in half, 6 and 5, I believe, and you randomly chose suit names for each of those piles, and then we just put things back together. How did you just happen to choose a card name and 2 randomly chosen suits that would lead to this outcome, that would actually reconstruct the packet exactly as it was? How in the world did you do that? Okay, so anyway, that is a kind of fun application I thought of weaving these two together. And of course, I should point out that any of these here, if you divide them in half as well as you can, right? So like 8 divides into 4 and 4. Well, 4 is on our list over here. 9 divided in half, the best we can, would be like 4 and 5 or 5 and 4. Both of those are here. 10 divided in half is actually 5 and 5. There it is. And then 11 is what we just did. That would divide up into 5 and 6, or 6 and 5, and both of those are here. So anyway, that's just a simple example of how you could actually weave these two false shuffles together and get a very, very surprising and apparently extremely unlikely outcome. So that's what I wanted to share with you today. A couple of amazing false mixing procedures. The first one applies to packets of size 8 through 11, and the other one applies to packets of size 4 through 6. So have fun with that. And the thing to do is just squirrel this away. And if you've watched my channel, we have worked with these packet sizes a lot. So for example, the classic lie detector test, where you have the spectator state their claim card that they saw, and then you spell it out and discover that they were lying, that involved 9 cards. Well, what that means is we could have, before even beginning that performance, we could have used this false mixing procedure to give the appearance that we've scrambled the cards according to the card named by the spectator. Wow. So they would even think you're starting just a random ordering of the cards before you even begin that procedure. Isn't that amazing? You could also apply this at the end, that once you go through the spelling procedure for the lie detector test, you could do this kind of thing here, and guess what? It leaves it where it was. It won't hurt the finale at all. Okay? So anyway, I'll leave that for you to experiment and try out different card values. And then if you're really interested in understanding now how does this work, then take a look at the Hidden Structures Boot Camp series. This idea of hypercoding is very, very powerful. So thank you for watching.